This is a banana, and this is my computer. And today I want to introduce them. I'm going to use Python to teach my computer how to recognize this beautiful fruit. The first thing we need to do is to find the data on which we'll train the model. I decided to search for data on Kaggle site, and I found a lot of datasets with fruit. I chose one with the banana, downloaded it, and found 3 folders with images. The train and test folders are needed during model training. The train folder is needed to train the model to find patterns, and the test folder is used to check the intermediate result during training. And in prediction folder, there are already some photos that we will recognize, but you can also replace them with your own. And after the hardest part of the project is over, we can move on training the model. At this stage, we need to get Miracle file weights h5, which will contain the trained model and which we will use in the last stage. To do this, I use the magic errors from TensorFlow library. What do we need to know about the trainpy file? There are 3 main stages. First step is data preparation, where we take the images from the train and test folders and make more data from them using various transformations, like rotate, rescale, zoom, etc. After that, we describe the architecture of our model. We have different layers that help the model analyze the image. First, simple features, then more complex one, and finally the model concludes which class the image belongs to. Finally, we train the model using our training data and evaluate its performance on the validation data, and save the file with trained model. In the prediction file, everything is much simpler. We just load the image, predict, and output result through a convenient interface. After that, I went to the store and bought some test fruits. I took a lot of photos from different angles and added some photos from the internet. As you can see, our model is pretty good at identifying banana and avocado, with only 2 images that were classified incorrectly. It turns out that we got about 91% accuracy, which is pretty good.